Hello, welcome to an inspiring math video. I am Francisco Pivera. The first law talks about multiplication. When you're multiplying terms with the same base, you will add the powers. So here we have the same base, which is 2. We'll add the powers 5 and 3. That gives us 2 power 8. When you divide, you will subtract the powers. The base is 5. The power will be subtracted, 7 and 3. That gives you 5 power 4. The third one is power to a power. When you have a power raised to another power, you will multiply. In this case here, we have power 3 and power 7. So these two are being multiplied. 3 times 7 is 21. In the fourth law, anything raised to the first power is the same thing. So raised to the power of 1, we write it without the power of 1. 17 power 1, we write it without the 1. In the next example, we have raised to the 0 power. When the power is a 0, our answer will be 1. 34 raised to the 0 power, the answer is 1. The sixth law talks about a fraction raised to a power. If we have a fraction a over b, we will have a power m and b power m. In other words, we'll be raising each value in the fraction to the power that is given. The example here, 5 over 6 squared. So 5 will be squared and 6 will be squared. 5 squared is 25, 6 squared is 36. In the seventh example, we have raised to the power, raised to a negative power. We cannot keep our answers as a negative power, so we need to write it as a denominator, and that causes the sign to change. So we write it under as a denominator, and we have the 1 as a numerator. And you might be wondering, why do we have a 1? Well, the factors of a are 1 and a. So if we bring down the a, we are left with 1, the factor of 1, as the numerator. So 9 with a negative 2. Power is negative 2. So for this here, we will have to write 1 over 9 squared, which is 81. 9 squared is 81. The last scenario here is when the power is a fraction. The numerator of the fraction, the numerator is the power. The denominator is the root. So x will be the power inside and y is the root of that value. So if we have 49 raised to the power of 1/2, 1 is the power and 2 is the root. So we are doing the square root of 49, which is 7. So these are the laws of indices that we'll be covering at this moment. Let us focus on the first example here. When we're multiplying with the same base. The same base, or the base here, is 2. We will have 2, 3 plus 5. When we are multiplying, we'll add the power. So 2 power 8. We'll grab our calculator and we'll do 2 power 8. 2 power 8 is 256. Our second example, the base is 3, and we'll add the powers. 2 plus 4 plus 0. So 2 plus 4 plus 0, that is 6. So we are working with 3 power 6. Our calculator gives us 3 power 6. 729. 729. Our next example, the base is 5. And we'll add the powers, 3 plus 5. So 3 plus 5 is 8. So 5 power 8, 5. This button here is the power, 8. 5 power 8, 390,625. 390,625. Our next example includes variables or letters. So we go through the same pattern. We say 4, the number here is 4, that's the same base. So we'll add the powers of each number 4. So we have 5 plus 3 plus 2. We have 5, 3, and 2. Now we need to write f as the common base. The values are 2, 2, and 3. So we'll say 2 plus 2 plus 3. Very well. Adding gives us 5 plus 3 is 8, 8 plus 2 is 10. 2 plus 2 is 4, 4 plus 3 is 7. Okay, 4 power 10. 4 power 10. That gives us 1,048,576. 1,048,576. F power 7. In this example, the common base here is 5. The powers for 5 will include or are 3 plus 3 plus 2. The power of f, the powers for f include 4 plus 5 plus 3. The 4, the 5, and the 3. So that gives us 5. 3 plus 3 is 6. 6 plus 2 is 8. And the f is raised today. 4 plus 5 is 9. 9 plus 3 is 12. Now we want to find 5 power 8. 5 power 8. 390,625. 390,625. F power 12. So that is multiplying with the same base. Now we want to focus on division with the same base. In the first example, we keep the base and we subtract the powers. When you divide, you subtract the powers. So 5 take away 2 is 3. And 2 raised to the third power is 8. We can try it in our calculators. 2 power 3 is 8. Our second example for division, the base is 3. 6 take away 4. So that's 3 power 2. 3 power 2 is 9. 3 squared is 9. Let's focus on the next example. Here we have 8 divided by 4. 8 divided by 4. F will subtract the powers. 9 take away 2. So 8 divided by 4 is 2, and 9 take away 2 is 7. So that's the answer for this example. Let us focus on this in this example now. We have 10 divided by 2. If you notice, the 10 doesn't have a power, the 2 doesn't have a power. So we just do the division. Now for the h, we have to follow the concept of 5 minus 3, where we subtract the powers. 7 minus 4. So dividing 10 by 2, that gives us 5. Subtracting the powers for the h, we get 2. Subtracting the powers of r gives us 3. And that's our answer. Now we want to focus on power to a power. According to the rule, power to a power, we will multiply. We will multiply. Multiply powers. We have 2 power 3 raised to the 7th power. So we'll say 2 power times the power. So 2 power 21. 2 power 21. 2,097,152. 2,097,252. 152. 150. In our second example, what is the power of the number 2? The number 2 has no power. The power is 1. So we'll say 2, 1 times 4, a, 3 times 4. Power to a power, we multiply. So 2 power 4 and a power 12. Now we need to evaluate 2 power 4. 2 power 4 is 16. A power 12. 2 power 4 equals 16. So 16, a power 12 is the answer. Now power of 1. A power 1 is equals to a. In other words, we write it without the power of 1. So here the answer will be k. Here the answer will be 22. And here the answer will be 16j. In other words, we do not write the power of 1. What about the power of 0? Anything raised to the 0 power is 1. So k to the 0 power, the answer is 1. 22 raised to the 0 power is 1. 16 raised to the 0 power is 1. J raised to the power of 0 is 1. So anything raised to the 0 power is 1. Now we want to focus on negative powers. If we have a raised to the negative 3 power, we need to change this negative 3 power. We need to make it positive. To make it positive, we bring it down into the denominator. Why denominator? If you notice, a negative 3, that is considered as a whole number, right? Now, if you notice, we have a fraction 1a power 3. In other words, we form a numerator and a denominator. So a negative 3 goes under and the sign changes. The sign changes here, becomes positive. But we don't have to write the positive. Let us solve k negative 5 power. So we need to write 1 over k power 5, and the 5 becomes positive. So that's our answer. In our second example, we have 5 negative 6 as a power. So we'll write 1 over 5 power 6. Now we need to do 5 power 6. 5 power 6. 15,625. So the answer is 1 over 15,625. We can write it at a decimal, but it's okay in this case. Let's write it out, 6 squared. And what about the j? J negative 6. So we have to bring it down and write j power 6. Now we simplify 6 squared, which is 36, over j power 6. So that is the answer. 36 over j power 6. We bring down the j power 6 because that's the only one that has a negative. If 6 squared, if this one here had a negative in here, then we have to bring that down too. In other words, we'll have 36 at the bottom and we'll keep the 1 at the top. Now, we want to focus fraction to a power. What do we do when we have a fraction raised to a power? So the rule is that you will square each value independently by the square or by the power. In this case, a square. So we'll square a and we'll square b. So let's tackle the first problem here. We have 2/3 raised to the second power. So as the rule says, we will square each value. So 2 squared is 4 and 3 squared is 9. So the answer is 4/9. In our next example, we have 3/4 raised to the third power. So 3 raised to the third and 4 raised to the third. We will cube each value separately. So 3 power 3, 3 times 3, 9, 9 times 3 is 27. 4 times 4, 16, 16 times 4 is 64. Now, 3 over 7 power 4. 3 power 4, 7 power 4. So we put each value with the power of 4 in this case here. So 3 power 4, 3 times 3, 9, and then 9 times 3 is 27, 27 times 3 is 81. 7 times 7 is 49, 49 times 7. 49 times 7 is 343, and times 7, we get 2,401. 2,401. So this is our answer. We can say 7 power 4, 2,401. 3 power 4, 81. Either way. So 81 over 2,400. Now, what about when the power is a fraction? Well, very important. This fraction here, that's the power. Okay? The x represents power. The y represents the root. So we write the root outside and we write the power inside. X inside. So the top number goes inside and the bottom number goes outside. So let's solve this problem here. So we write 5, we write the root symbol, the 2 goes inside and the 3 goes outside. So we have to do what's inside first. So we need to do 5 squared is 25. Now we need to do the third root of 25. The third root of 25. Let's grab our calculator. So we write 25. We have to write the second function, which is shift in your calculator. We can click on this button here. That gives us the third root right away, automatic. If your calculator doesn't have the third root, then you have to press this button here, and then you have to indicate which power you want. But in this case, it has it. So we find the third root, which is 2.9. The answer here is 2.9. Let me do that once again. 25 shift third root, 2.9. Just be aware that some calculators operate differently. So you'll have to look at that scenario as well. Let us focus on 64 raised to the 1/3. So we need to write 64, our root. We write the power inside and the root outside. So it's a cube root of 64. Once again, 64 shift third root. The answer is 4. So our answer is 4 in this case. Now, the next example I will show you will help you when there is no specific button for that. Okay, like the square root, you know that your calculator has this as a square root because that's a 2. And then your calculator has this here, it has the cube root. What about the 6th root, the 7th root, the 8th root, the 9th root? So you have to press the button as I indicated earlier. So let's go through this one here. So 15, we write the root, the 2 is the power, and the 5 is the root. So as I mentioned earlier, we need to solve what's in the bracket first. In the bracket, we have 15 squared. So 15 times 15. 15 times 15, 225. So 225. Now we need to find the 5th root. The 5th root. Let's go through that process. 225 shift. Now, which root do we want to find? We cannot write the third root because that's not what we're finding. We have to press this button because this will now allow us to write any root we want. In this case, we want 5. If we wanted the 9th root, well, we click on 9. But we want the 5th root, then we press equal. So our answer is 2.95. Our answer is 2.95. Okay, so that is how you find the root or any root of a number here. If you think this video was helpful, click on the other videos to keep learning. Be safe.